Of the Heff and trial exam. What we need to do for this is use the chain rule. The reason why we need to use a chain rule is because we've got a particular function that's in another function. So what we need to do is first define y is equal to cos u, where u equals 1 minus x squared. So dy over dx is equal to, so the derivative of cos u is equal to sine u, and du dx is equal to negative 2x. In this case, since we're talking about the chain rule, we just need to multiply both this and this together and resubstitute the u back in. And so what we get is the answer being negative 2x sine 1 minus x squared. Alright, the next question is if f is equal to, as you can see here, find f dash of 0. What we need to do for this is use the quotient rule. So the quotient rule, because we've got a denominator and a numerator, and we're trying to find the derivative of that. So when you use the quotient rule, what you end up getting is f dash of x is equal to, we'll take u, and we won't find the derivative. So 1 plus e 2x times 2 cos 2x minus 2e 2x times sine 2x, all of that over the denominator squared. Alright, now we've got to be careful with this because we probably have a tendency at the moment to simplify. But before we simplify, we can work out this f dash of 0 component and see what we can substitute in so that we can simplify this a little bit more easily. So if we substitute 0 into here, this simplifies to 1. If we substitute 0 into the cos component, this simplifies to 1, so times 1. This one up here, this simplifies to 1, and this one here simplifies to 0. And when we've got the bottom, we've got, that simplifies to 1. And so if we evaluate now f dash of 0, we've got 1 plus 1 up there, which is 2, times 2 times 1, which is 2. That's the top bit. The second bit, we've got minus 1 times 0, so that pretty much disappears. And the bottom will be 1 plus 1, 2 squared. And so this simplifies to 4 over 4, which gives us 1. 2 talks about log e x plus 1, and you've got a restriction of the domain, and you've got g of x is equal to x squared. So we're trying to find FOG. So to find FOG, we're substituting g of x into log e x plus 1. So whenever we see an x, we'll write x squared. So this becomes ln x squared plus 1. The domain and range of FOG. So let's have a look at this graph at the moment. So when we're talking about the domain of fog, right? The domain of fog at the moment is if we look at this graph, log is not defined when we're trying to evaluate 0 or any negative value. When will x squared plus 1 be negative? So x squared is less than negative 1. In this case, there won't be an instance where this particular log is undefined. So in fact, the domain for this particular function is all real numbers. Now, since we've got all real numbers as a potential domain, we need to investigate the range. Now, this graph, okay, if we imagine it, it's going to look something like this, right? And since there's an x squared factor, there'll be a point at, for example, x equals -1 where it has a value of 0, but then it reflects off that way as well. So what happens is that now we can evaluate the range of fog, and we can see that everything above there, inclusive of 0, is a potential answer. Okay. So in this case, the fact that it's squared means that yes, we can evaluate at x equals 0, but if it in this case, we just have to be careful of whatever's inside the brackets. Question 3 looks at this tan graph, and with this tan graph, we're asked to find the average rate of change between x equals 0 and x equals pi on 8. So the average rate of change is essentially the gradient formula, and if we understand what we need to plug in, so this is our function f, right? So it's y2. So y2 in this case will be f on 8 minus y1, which is f of 0, over pi on 8 minus 0. Okay, and if we evaluate this, we need to first figure out what is f pi on 8. And if we look at what f pi on 8 is, this will be tan 2 times pi on 8, so 2 times pi on 8 is pi on 4, plus 1. And if we remember our values, tan pi on 4, that is 1. Okay, so we've got 1 plus 1, which is 2, so that's 2, minus f of 0, tan 0 is 0, tan 0 is f of 0 plus 1, so we go plus 1, so tan 0 plus 1 is equal to 1 over pi on 8. Okay, from this point, 1 we get 1 over pi on 8, and we find the reciprocal of this, so it becomes 8 on pi. All right, now the next question is asking us to solve for this particular equation. So if we write f of x down, f of x was tan 2x plus 1, and we're making that equal to 1 plus 1 over root 3. And we're trying to solve for this equation. To solve for this equation, we need to first rearrange. So we get tan 2x is equal to 1 on root 3. Otherwise, root 3 on 3. Now, we've got to work out what the basic angle is, or the reference angle is. So, the reference angle, where does tan equal root 3 on 3? At pi on 6. So now that we've got the reference angle as pi on 6, we have to have a look at which quadrants this exists in. So since it's a positive value, we draw up our cast. Okay, since it's a positive value, we want this and this. Alright, and so these equations, we're just going to check our domain. Our domain is from negative pi on 4 to pi on 4. So let's be careful with this. Alright, so now that we're going to try and solve this, right, we're going to incorporate the equation. So we're going to get 2x is equal to, the first one is going to be theta. Next one's going to be pi plus theta. Okay, and if we go in reverse, because I see a negative domain here, we're going to have a final equation of negative pi plus theta. Now, before we evaluate these next few bits, let's adjust the domain. Okay. And from this point, 2x means that we now evaluate this at pi on 2 and negative pi on 2. So we only want answers between these domains. So when we work these out, we get 2x is equal to, the theta one's going to be pi on 6. The adding one is going to be 7 pi on 6. And the last one's going to be negative 5 pi on 6. It's equal to 2x. Now from this point, let's solve for x. So x is equal to pi on 12, 7 pi on 12, negative 5 pi on 12. But since our original domain is only from negative pi on 4 to pi on 4, we want to reject all other solutions that don't fall within the domain. So our only solution for this one is this. Okay. Alright, so the next question says sketch the graph of g on the axis below. So we need to first understand what kind of graph we're dealing with. So this is just going to be taken as a copy and paste from the graph above. Alright, so the graph above indicates that there's some sort of graph, looks like that, some sort of tan graph. Now, what's happening with this tan graph? So I can see that there is a reflection in the y-axis. Okay, how do I know it's y-axis? Because we're affecting the x in this case. And then there is a translation of 2 units down. Okay, so let's try that out. Let's try with this blue graph. What would happen if we reflect this on the y-axis? Okay, if we reflect it on the y-axis, there would be a sorry about that. This graph that I've drawn is incorrect. We want to draw that graph. Okay, so if we look at the graph, there's a reflection in the y-axis and translated 2 units down. So all the y values will now be reflected, so that one will appear down here, and something that appears up here will now appear down here. And it looks like if it's translated down, it'll also look like that as such. Okay, now obviously that scaling is terrible. Okay, however, a couple of things are worth mentioning is that this point here needs to be identified as pi on 8. And how do we know that that's pi on 8? Well, it's one of the x-intercepts that we can calculate. And also this point here, if this is 1, 0, okay, this needs to be identified as 0, negative 1. Sorry, not 1, 0, 0, 1. That needs to be, yeah. So in this case, we've drawn the graph in the correct shape. 4 asks for this particular integral. Now for this integral, we have to remember that there's shortcuts to working out something that has a numerator as x plus 1, or x. In this case, if we separate this, we don't have to separate this, but it's just for so you can see where this is coming from. Okay, if we use our formula sheet, this integrates to ln x plus 1. Okay, but let's try this out a different way, just in case you've forgotten this. Okay, so we're going to make a u substitution. So we're going to let u is equal to, let u equal this denominator, which is x plus 1. And then we can find du is equal to, so du dx is equal to 1. And then after that, when we rearrange this, we get du is equal to dx. Okay, and then we end up getting if we take this 3 out to the front, we end up getting 3 is equal to 1 over u du, integral from 0 to, okay, we've got to change the bounds for that, but I'm going to change it back, so I'm going to just ignore that for now. And then from this point, the integral of, or the interderivative of 1 over u is log u, so this becomes 3 ln u, but u I can substitute back into x plus 1. Okay, we want to evaluate that from 0 to e minus 1. So you end up getting to that point anyway, but I strongly suggest that if possible, you learn the shortcuts for this. So this becomes 3 ln e minus 1 plus 1 minus ln 0 plus 1. Okay, and this crosses out. Ln of 0 plus 1 is, so ln of 1 is 0, so this becomes 3 ln e, and ln of e crosses out, that becomes 3. Alright, next component says, given that f of x is equal to that, and you're given the derivative, find f of x. So we're trying to find f dash of x is equal to 2 sine pi x. Okay, so at this point, the antiderivative of sine is negative cos, and whatever's on the inside, it's going to be 1 over that. So we get f dash of x, so f of x is equal to 2 over pi, there's a negative at the front because it's negative cos pi x. And don't forget the plus c. Alright, the reason why we need to make sure we remember the plus c is because now when we equate it to this information that's over here, we get 0 is equal to negative 2 pi cos pi on 3 plus c. And if we solve for c, we'll get an answer that satisfies the question. So let's try this out. What's cos pi on 3? Cos pi on 3 is equal to 1/2 plus c is equal to 0. And if we solve and rearrange this, it becomes 0 is equal to negative 2 over 2 pi plus c. c is equal to 2 on 2 pi. Okay, c is equal to 1 on pi. So this becomes our final equation of f of x is equal to negative 2 pi cos pi x plus 1 over pi. This next one here is a product rule question because we've got two separate functions here that we're trying to multiply, and I'll find the derivative. So let's do that by using the product rule. So dy dx is equal to, we're going to call this u and we're going to call this v, and we're going to go u dash v plus u v dash. Okay, we end up getting 2x log e 2x plus x squared times 2 over 2x. And if we simplify this, this becomes 2x ln 2x plus 2x squared over 2x. And this simplifies to x. Alright, now this next question says, hence find the average value of the function for this. And to find the average value, let's first understand what the formula is. I'm going to pause this one. This is quite a hefty question, but let's take it step by step. So first, it's asking us for the average value. So the average value, we can define that by saying 1 over the endpoint minus the starting point of the particular integral that we want to find. So a half to 1 for f of x dx. All right, so if we work this out, f of x dx, so this first part here simplifies to 2, and we're going to find the integral from half to 1 of x log e 2x. Okay, now from this point, we're going to leave it at this. What we're going to do now is use the information that we got from the previous question here. Now, the previous question, if we interpret this information such that we get 2x log e x plus x, and I want to find the integral of that, that equals x squared log e 2x. Alright, so what we need to do now is we need to find a way of how we can represent this particular equation that we've got here and use the information that we've got here so that they match up and line up. One way we could do this is by recognizing that this part here, we've got the 2x log e. We can work with those things, and this thing in blue, we're going to move to the other side. Okay, so this will end up becoming 2x log e x, and if I want to find the integral of that, that equals x squared log e 2x minus the integral of x dx. All right. Now, from this point, we can actually just work with this equation that we've got here. And in fact, we're going to integrate this component. And when we integrate this component, we'll end up working out our values that we can substitute. So the average value is the analysis or the evaluation between the terminals that we have. So let's work this out first. So x squared log e 2x minus x on 2 squared plus c. So this is our crucial step at this point. What we're going to do from here is now evaluate our terminals. And the terminals that we wanted was to go from a half to 1. Now, to go from a half to 1, we then make that substitution, and when you make that substitution, that becomes 1. I'm going to forget about the 1. That becomes log e2 minus half. We're going to forget about this plus c. Subtract half squared log e1 minus half squared on 2. Whew. This crosses out because we are evaluating log 1, which is 0. Okay, and we can go to the next step. This becomes log e2 minus a half plus 1/8, because 1/2 squared is 1/4, half of a quarter is an eighth. And then when we add these two together, we get log e2 plus 3/8. We're very close to our final step, because our final step is now asking us, sorry, no, that's minus. Our final step's just asking us to represent it in that form, so we're just going to change one small thing and say log e2 minus 3 over 2 to the power of 3, and you've got your answer. question 6 talks about proportions, and with this proportion, we're asked to find the expected value. Now, checkouts that are occupied by customers. This one's a bit of a tricky one because we need to understand that it's really, we can apply binomial theorem with this one, but we're talking about this value here, which proportion, probability of 0, which indicates that we can use a binomial distribution. Now, when we've got expected value of a particular proportion, we can define that as P. So when we talk about the probability that the proportion sample is equal to 0, okay, which is what we've got here, we can equate that to 4 C0, okay, why 4? Because we've got 4 checkouts. Why 0? Because we're choosing 0. Probability to the power of 0, and then 1 minus P, the complement, to the power of 4. Now we know that that equals 1/4. How do we know it's 1/4? Because it's 0.25. Now if we evaluate this, we can then solve for P, because 4C0 becomes 1, P to the power of 0 becomes 1. We end up having 1 minus P to the power of 4 is equal to 1/4. Now, when you have got something to the power of a quarter, you can take the square root and take the square root again. But just to really drive in the point so you understand what's going on, let's take only the square root, because at the moment we've got a fourth. So in other words, if we had 1 minus P square root over a quarter, this would simplify to 1 minus P is equal to 1 square root of 4. But since we've got a 4 here, we've got to do that twice. So let's see what happens. So square root is equal to square root of 4 is 2. And if we take the square root again, we get 1 over square root of 2. Now be very careful with this one, because we're not finished with this question. And also, whenever you take the square roots, you have to remember you've got a plus, a positive and a negative component. And we've got to solve for P. So P is equal to positive, negative 1 over root 2 minus 1. Okay, and if we oh, careful, ooh, nearly made this mistake. That's negative P, so that means we make this positive, positive. Okay, and this becomes as such, negative. Just to be sure, let's rewrite this. P plus minus 1 over root 2. Then we're going to subtract 1 from it. So this becomes plus minus 1 over root 2 plus 1. There we go. But since we're dealing with probabilities, we only have one answer that we want to consider, and that is the one that's in between 0 and 1. So 1 over root 2 is under a half. Under a half plus 1 will be too much. So we need to take the other component, which is 1 minus 1 on root 2. Okay. The other way to think about it is that if you've got 1 and you're adding 1 to something, if you have a positive number, straight off the bat, it's going to be over 1. This number in yellow is going to be over 1 already, so that has to be discounted. Alright, question 7. It's asking for the stationary points of this graph. Now, to find the stationary points of this graph, we want to find where f dash of x equals 0. Now, to find f dash of x equals 0, let's rearrange this equation such that we've got f of x is equal to x plus x minus 2 to the power of negative 1. And then we can use the chain rule, or we just need to make sure we're careful with it. So we get f dash of x is equal to 1 plus negative 1 x minus 2, and the inside of it, derives to 1, so we don't need to make that adjustment, but we need to subtract 1 from the power. And that's it. You should probably express this as a positive index. You get that. Now, we want to find where are the stationary points. So this is f dash of x. So now, let's solve. Let's solve this for equal to 0. So when we solve this for equal to 0, we get negative 1 on x minus 2 squared is equal to negative 1. Cross, cross. 1 is equal to x minus 2 squared. 1 is equal to x squared minus 2x, so minus 4x, sorry, plus 4. Actually, from this point, we could even just square root of 1 is plus minus 1. X minus 2, x is equal to 2, or 3 or 1. Now we have to make sure we substitute it back into the original equation. So when we substitute 3 into here, we get y is equal to 4. And when we substitute 1 back into here, we get equal to 0. So therefore your coordinates are 3, 4, 1, 0. So it's saying find the values of C for which a translation, a vertical translation, has no solutions. So we know that this is 3, 4, and this is 1, 0 down here. So you can shift this graph up and down, but when you shift this graph up and down, there will be a point where there's no solutions. So the no solutions would be in between. If you shift it down 4 units, or if you move it, if there's no translation, it'll be a single point. So you only want to move the graph between 0, the values of C. Sorry, let me just rehash what I'm trying to say here. Let it be a little bit unclear. There's a particular section here. Now with this particular section, if this graph remains as it is, there will be 1 intercept here. So if we keep moving the graph down, so if C is equal to negative 1, C is equal to negative 2, C is equal to negative 3, so on, that graph will move down, there'll be no intercepts. But the moment we move it down 4 units, there will be an intercept. But if we move it down 3.99 units, there'll be no intercept. So therefore, the value of C can lie between negative 4 and 0. And the next question says, find the values for which this particular equation has no intercepts. So to work this out, we need to substitute in what this would look like. And if we substitute this in, we get y is equal to 1 plus a minus x, and that's equal to 1 plus a minus x plus 1 over a minus x minus 2. Okay, the y-int is x equals 0, so we substitute x equals 0, that crosses out, and so we end up getting y is equal to 1 plus a 1 over a minus 2. Okay, so you can see with this graph, if we move it across left and right, there will be a point where it has no y-intercepts, and that's the asymptote, such that when a equals 2, that will be the case. Question 8 talks about showing the probability density functions. So it says show that a is equal to log E3. So to show this, what we're going to do is we're going to say that the endpoints that these values are the same. So we've got e to the power of x minus 1 should equal 6e to the power of negative x. Now, where does this occur? At x equal a. So let's do that. E to the power of a minus 1, 6e minus 1. A. Okay. So from this point, what we're going to do is we're going to rearrange this. So that's e to the power of a minus 1 minus 6e to the power of negative a is equal to 0. Now, I'm going to multiply everything on this side by e to the power of a. And so I get 0 times e to the power of a. And what I end up getting is e to the power of 2a minus e to the power of a minus 6, okay, because they cross out. And what happens is that you can factorize this by using quadratic factorizing. So this becomes e to the power of a minus 3, e to the power of a plus 2 equals 0. And so therefore e to the power of a equals 0 equals minus 3 equals 0, or e to the power of a plus 2 equals 0. E to the power of a is equal to 3. E to the power of a is equal to negative 2. So a is equal to log e3. A is equal to log e negative 2. That doesn't exist, so this is our only answer. Next question says, evaluate the probability from A to B. Now, the probability of A to B is the same as saying probability of A x to B is the same as saying 1 minus the probability of 0 to x of A. Now, how does that work out? Well, imagine you've got two graphs, and this graph happens to look like this, right? That's the first section. And you've got the second section that looks like this. When you've got the first section, to work out this red probability, if we go 1 minus whatever this is, that'll give us the other section. So, we know the total probability of this is going to equal 1 as well. So let's evaluate this. The integral from 0 to a for, in this case, is log e3, as we found out in the previous question. Log e3. Okay, of e to the power of x minus 1 dx. Alright, from this point, the integral of, or the antiderivative of e to the x is e to the x, and the integral, or the antiderivative of negative 1 is negative x from 0 to log e3. And then we evaluate this, e to the power of log e3 minus log e3. Okay, subtract that with 0, 0. That negates itself. I'm not going to bother running that one out. Actually, I've got to be careful because e to the power of 0 is 1. E to the power of 0 is 1. So e to the power of 0 minus 0. Okay, that becomes 1. This cancels out. That 3 comes at the front. So it's 3 minus log e3 minus 1. And if we 3 minus 8, and this becomes 2 minus log e3. Now we're going to be careful with this because this thing that we've calculated right here is that. So what we're going to do is just take that one more step and go 2 minus, so 1 minus 2 minus log e3, which gives us log e3 minus 1. All right. Now, this next question here. Hence, find the value of b. Ugh. All right, let's do this. So to find the value of b is, let's understand, is the endpoint. So we want to find the endpoint. So we've got log e3 to b, and the function that we're dealing with is 6e to the power of minus x dx. Okay, that's correct. And what does that area equal? That area equals this. Log e3 minus 1. All right. Let's evaluate this. So, now that we know that that's the case, what we're going to do is we're going to evaluate this side first. Okay, so we're going to focus on this side. Now, let's find the antiderivative of 6e to the power of negative x. The antiderivative of that is negative 6e to the power of negative x. And we can evaluate that from log e3 to b. Okay. Now, by doing this, we get negative 6e to the power of negative b minus negative 6 e to the power of negative log e3. And then we're going to do the other side. So let's simplify this. So in order to simplify this, we'll take that negative at the top. So this becomes negative 6e negative b plus 6e log e 1/3. All right. So we take that 1/3 at the front. That becomes negative 6e negative b plus 2. That cancels out. And we've evaluated our integral. So 6 minus 6e negative b. So we've evaluated that equation on the left. So this is this. Now we can equate that to log e3 minus 1. All right, then from this point, when we rearrange it, we get negative 6e negative b is equal to log e3 minus 3. Okay, and then we divide both sides by negative 6. We get e to the power of negative b is equal to, so if we divide this all by negative 6, this becomes 3 minus log e3 over 6. And then we can find the logs of both sides. So log e, this becomes negative b is equal to log e 3 minus log e 3 over 6. And then after that we take this negative over to the other side. Okay, so that becomes negative. But remember, with logs, if you've got a negative there, you can take it to as a power. And if it's to the power, then this becomes b is equal to log e 6 over 3 minus log e 3. And we end up getting what they've asked for in that equation. On to question 9. It says part of the graph is shown, and with this graph you've got a bounded area. Now it says show that the equational line through a and b is given by this particular equation. So a is over here, b is over here. You're trying to find the gradient, and with the gradient find the y-intercept. So what's the value of b and what's the value of a? x int y equals 0. So if y equals 0, you get 0 is equal to root 3 minus x. 0 is equal to 3 minus x. X is equal to 3. Now, to find the y int, we get x equals 0. So we get y is equal to root 3. Alright, so now we can find y2. So this is, therefore your coordinates are 3, 0, and this one's 0, root 3. So y2 minus y1 over x2 minus x1. Root 3 on negative 3. Alright, from this point we could go y minus y1. Actually, you know what, let's use y is equal to negative root 3 on 3 x plus c. We can substitute point A into there. So we get 0 is equal to negative root 3 on 3 times that by 3 plus c. Cancel, cancel. C is equal to root 3. So therefore, y is equal to negative root 3 on 3 x plus root 3. 2 marks of this one, showing the intercept and showing the gradient. Question B now asks us to find the area of the shaded region. Now, to find the area of this shaded region, there's 2 ways you could work this out. You could work out the bounded area between the two, or you could work out the area of this total section and then subtract it by this rectangle that you see, or this triangle that you see on the bottom here. I'm leaning towards the first approach, where we subtract the top line from the bottom line. So the area is equal to the integral from 0 to 3, but we're going to subtract the top line, 3 minus x, from the bottom line. And the bottom line we worked out just then was root 3 on 3 x plus root 3. And then we're going to put the dx at the end of it. Alright, from this point, turn this to a power of a half. Okay, we can find the integrals of this separately. So it's from 0 to 3. This one's going to be 3 minus x. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, but don't forget to multiply with whatever the derivative of the inside is, so that's negative 2/3. Chain rule, so for those of you that skip that one, you have to use chain rule for that one. And then we add, so that's add 1 to the power, but divide by the new power, so that's root 3 on 6 x squared minus root 3 x. Okay, so we can evaluate that from 0 to 3. Let's skip a couple of steps. So we get root 3 on 2 minus 3 root 3 plus 2 root 3. And then after that, this ends up becoming 3 root 3 on 2 minus root 3. And when you've got 3 halves, so think of this as 1.5 root 3 minus root 3. When you subtract the 2, you get root 3 on 2 left, so half of root 3. Alright, question C says find the derivative of f. So f in this case was root 3 minus x. So root 3 minus x. To find the derivative of this, you get 3 minus x to the power of a half. Chain rule, derivative multiply down by the power. Okay, but don't forget to multiply by its derivative in the inside, so you get 3 minus x. Okay, and if we express this as a positive, as a positive index, okay, we get 1 over 2 square root of 3 minus x, and that's it. Okay, but don't forget, with derivatives, you take away from the power. With antiderivatives, you add to the power. All right, last question. It says here the point. Find the coordinates where point P when the theta equals 30 degrees. So what I can say with this question is as follows. If I look at A, O, B, okay, I see 30 degrees right there. Now, how do we know that that's 30 degrees? Well, we know it's 30 degrees because this height is root 3, and this height here, or this length, is 3. And if we work out tan theta is equal to root 3 on 3, where does tan theta equal root 3 on 3? In this case, pi on 6, so 30 degrees. Okay, so we know that that's 30 degrees. Now, from this point, what we need to do is we need to work out that if this is 30 degrees, on the other side, the remainder of this will be 150 degrees. Okay, so wherever it goes to will be 150 degrees because it's a straight angle. So in order to do this, if we reflect that triangle, if this is 30 degrees over here, the remainder of this will be 120 degrees. Okay, so this component here will be 120 degrees. Now, since we know this is 120 degrees, we know that the tangent, or the angle that it makes with the positive direction of the x-axis, f dash of x is equal to tan 120 degrees. And so where is tan 120 degrees? What's that equivalent to? Root 3, because if we look at cast, okay, tan 120 over here, so it's a negative root 3 value. For those of you that are wondering, 180 minus 120, 180 degrees minus 60 degrees gives us 120. So we've split it up that way. What's tan 60? Root 3, negative quadrant. That's your answer.